What happens when AI systems become investigators, memory banks, and accountability tools all at once? In this episode, we explore three fascinating frontiers: agentic program analysis that hunts down privilege escalation across complex microservices, personal visual context learning that tries to make multimodal models understand your own life, and canary-based attribution methods that trace an AI agent back to its owner. Together, these papers reveal how today's AI is moving beyond prediction toward active reasoning, personalization, and responsibility. Let's explore the first paper: Detecting Privilege Escalation in Polyglot Microservices via Agentic Program Analysis. Detecting privilege escalation in polyglot microservices via agentic program analysis presents Neo, an LLM-driven security analysis framework that combines Claude Sonnet 3.7 with CodeQL-based program analysis to detect cross-service privilege escalation in heterogeneous microservice codebases. The core novelty is a small set of language-agnostic code search primitives: QName, cost, QFlow, QCG, QSource, Kinter, and QGlobalFlow that let the agent iteratively identify privileged operations, trace data from external inputs across service boundaries, and validate whether authn, authz checks actually protect a specific sync. Evaluated on 25 open source microservice applications spanning 7 languages and 6.2 million lines of code, Neo uncovered 24 zero-day privilege escalation vulnerabilities and achieved 81% precision and 85% recall on a ground truth set of 20 verified vulnerabilities across 4 applications. Across both datasets, it reported 39 true positives with 12 false positives for 76.5% precision overall. The ablation study shows why the design matters. Removing application-specific privileged operation discovery drops recall from 92.9% to 33.3%, and removing the code search primitives reduces recall to 4.8%. Compared with MScan, CodeQL, and NIGMA, Neo found substantially more vulnerabilities, including 24 more than NIGMA in one comparison set. Beyond privilege escalation, prompt-only retargeting let it find 18 additional zero-day command injection and SQL injection issues, showing that the agentic search and validate loop generalizes beyond a single vulnerability class. Let's explore the second paper: Personal Visual Context Learning in Large Multimodal Models. Personal Visual Context Learning, personal VCL, defines a new capability for large multimodal models, using user-specific visual history at inference time to answer personalized queries. The paper introduces Personal VCL Bench, a 2,255 example benchmark built from EgoLife, Ego4D, and Captain Cook 4D, spanning 7 tasks across persons, objects, behavior, and the capstone EgoWare identification. On frontier models including Qwen 3, VL8B, Gemma 431B, and Gemini 3 Flash, the authors find a modality paradox and a scaling paradox. Raw visual context often underperforms textual descriptions, and adding more context frequently fails to improve accuracy. For example, on Gemma 431B, visual context prompting on EgoWare identification reaches 55.36%, while language context reaches 52.99%, showing no reliable advantage for raw pixels. To address this, they propose the Agentic Context Bank, an inference time memory system that extracts typed entries such as appearance, owned, objects, and behavior, merges them with ADD, confirm, revise, retract operations, then performs query adaptive evidence selection with a 2-stage LMM call. This structured baseline improves Gemma 431B from 55.36% to 61.6% on EgoWare identification and raises overall benchmark performance, including behavior error detection from 59.46% to 66.22%, and object detection from 71.74%, language context accuracy to 73.19%. Let's explore the third paper: Who owns this agent? Tracing AI agents back to their owners. Who owns this agent? Introduces agent attribution, the problem of tracing an observed AI agent interaction back to the operator's vendor account. The paper's core contribution is a canary-based protocol for vendor-hosted LLMs. An authorized authority injects a canary into content the agent is likely to consume, and the vendor searches a bounded session lock window around the injection time to recover the session and account. In non-adversarial settings, a single lexical canary is enough, and achieves near-perfect attribution. In communication agent experiments on Quen 2, 5, 7b, instruct chat and forum data. Lexical canaries reach TPR is approximately equal to 1, with FPR is approximately equal to 0. For adversarial operators who paraphrase input, the authors propose utility-bearing lexical canaries and semantic canaries, where meaning rather than exact token sequence is detected by classifiers over cached representations. On chat, a multi-label GRU probe over frozen Quen 257b, instruct activations achieved macro AUC 0.98 and session level TPR is approximately equal to 1. At FPR is approximately equal to 0.01 with 20 semantic canaries. On web pages, a modern BERT-based multi-label classifier reached average AUC 0.992 non-adversarial and 0.974 after paraphrase. In 15 Flask-based web CTF challenges using Quen 3.59b, utility-bearing canaries showed the key asymmetry. A canary-aware adversary cut solve rate from 51% to 9% by stripping task-critical content, while attribution stayed above 90% at low false positive rates. Vendor site search scaled linearly with the number of sessions in the attribution window, and token-level matching was about 2 times faster than character search. That's a wrap on today's AI paper highlights. Thanks for watching.